Welcome to Statistics Made Simple, and I am Savita Valsang. This video will find solutions to problems based on Newton's advancing difference method for interpolation. Under Newton's advancing difference method, we'll study about Newton's method of interpolation. Now, this method is applicable in cases where the values of the independent variable increases at equal intervals. Also, the values of y which are to be interpolated need not correspond with any of the given values of x. For example, if we take the table which is given, the x values are 10, 20, 30, 40 and 50, and the y values are 100, 120, 130, 140 and 150. So we have labeled the x values as x0, x1, x2, x3 and x4, and similarly the y values are labeled as y0, y1, y2, y3 and y4. If we observe this table, the x values are all equally spaced. Now in this table, we can interpolate the values of y for x equal to 12, 25, 43, even though they do not belong to the given table. Newton's formula for interpolation is a pretty long one, so you need to practice the formula repeatedly. The formula is given by yx equal to y0 plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cubed plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial delta naught to the power 4 plus so on, where y naught is the value of y at the origin, delta naught to the power 1 is the first leading difference, delta naught square is the second leading difference, similarly delta naught cube is the third leading difference and so on. Yx is a value of y which has to be interpolated for a given value of x. And x is calculated using the following formula, that is x equal to value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x, and x naught is the value of x at the origin. Now here when I am explaining this, it may be little difficult to relate to the notations. Once we start the problems, you will be able to relate to the notations very easily. Let us now learn how to form Newton's advancing difference table. Now usually in a problem, only the x and y column will be given. The leading differences have to be found out, and I'll be explaining it from the given table. Now in the first column, if you observe, I have taken the x values as x0, x1, x2, x3 and x4. The y values are y0, y1, y2, y3 and y4. The leading differences will depend on the problem which is given. So the first difference is denoted by delta to the power 1. The second difference is denoted by delta square. The third difference is delta cubed, and the fourth difference is delta to the power 4. Now how do we find out the first difference? If you see, the first difference is nothing but the second y value minus the first y value, that is y1 minus y0, and this is equal to delta naught to the power 1. Similarly, y2 minus y1 is equal to delta 1 to the power 1, y3 minus y2 is delta square to the power 1, and y4 minus y3 is equal to delta 3 to the power 1. So, if we find out the differences of the y values, we get the first difference. Now we'll calculate the second difference, which is denoted by delta square. And how do we find out the second differences? If you observe, it is nothing but delta 1 to the power 1 minus delta naught to the power 1, which gives us delta naught square. Then delta 2 to the power 1 minus delta 1 to the power 1 gives us delta 1 square. And similarly, delta cube to the power 1 minus delta square to the power 1 will give us delta 2 to the power 2. Now to find out the third differences, which are denoted by delta cube, it is nothing but the differences of the previous column. So delta 1 square minus delta naught square will give us delta naught cubed, and delta 2 square minus delta 1 square will give us delta 1 cube. And to find out the fourth difference, that is delta to the power 4, it is nothing but the difference between the previous column, that is delta 1 cubed minus delta naught cubed is equal to delta naught to the power 4. You will observe that whenever we are finding out all these differences, we are writing the difference between two values, and also the leading difference table should be stopped when we have only one value left in the last column. And keep in mind that Newton's formula should be used when the value to be interpolated is in the beginning of the table. Again, this particular table looks very complicated, but you will see that once we put some numbers into the table, you will understand the concept very easily. Starting with the problems. Problem 1. From the following data given below, estimate the number of persons living at the age of 25 years. So, note that in all interpolation and extrapolation problems, only the first two columns will be given. The leading differences are what we are going to find out, and all that we find out in the problem I have highlighted in pink color. So in the first column, you are given age in years as 20, 30, 40, 50, and number of persons as 53, 49, 36, and 23. Now the first step is to mark age in years as X and number of persons as Y. And the first value in the X column, that is 20, is marked as X0. So it is the value at the origin. And number of persons, the first value which you have is 53, that is marked as Y0. Now we will find out the leading differences, that is delta to the power 1, delta square, and delta cubed. Now in the question, they have asked us to estimate the number of persons living at the age of 25 years. So 25 years is an X value which lies at the beginning of the table. Now let us find out delta to the power 1. Now be careful with the signs when we are finding out the differences. So how do we find delta to the power 1? It is nothing but the second y value minus the first y value, and then the difference which we get is written between these two values. So 49 minus 53 is equal to minus 4, and this we call it as delta naught to the power 1. Similarly, find out the next difference, that is 36 minus 49 is equal to minus 13, and this value is written between 49 and 36. Then find out 23 minus 36, which is equal to minus 13, which is written between 36 and 23. Now find out the second leading differences, that is delta square. So how do you find out delta square? It is nothing but the difference of the previous column. So minus 13 minus of minus 4 gives us minus 9. We call this as delta naught square, and this is written between minus 4 and minus 13. Similarly, the next difference is minus 13 minus of minus 13, which gives us 0, and 0 is written in between minus 13 and 13. Now the last column is delta cube, and how do we find out delta cube? It is nothing but the difference of the previous column. So 0 minus of minus 9 is equal to 9. Call it as delta naught cubed, and this difference is written in between 0 and minus 9. We stop the table because we have only one value left in the last column. Starting with the solution, write Newton's interpolation formula. Consider yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cubed. And x is value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x. So you get x equal to value of x for which y is interpolated is nothing but 25. That's what is asked in a question. Value of x at the origin means x naught, that is 20, divided by difference between two adjoining values of x means difference between the two x values, that is 30 minus 20. So it simplifies to 5 divided by 10, which is equal to 0.5. Substituting, you will get, which implies y, the subscript will be 25 equal to 53 plus 0.5 into minus 4 plus 0.5 into 0.5 minus 1 by 2 factorial into minus 9 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 divided by 3 factorial into 9. So all these values are substituted from the table, which simplifies to 53 minus 2 plus 0.5 into minus 0.5 divided by 2 factorial is 2 into minus 9 plus 0.5 into minus 0.5 into minus 1.5 divided by 3 factorial is 6 into 9. On simplification, you get equal to 53 minus 2, that is 51, plus 1.125 plus 0.5625. Therefore, y25 is equal to 52.6875, which is approximated to 53 because we are talking about the number of persons. So you will get the number of persons living at the age of 25 years is 53. 2. Following is the data regarding annual net life insurance premium. Using Newton's method, estimate the premium at the age of 26 years. The first two columns are given, that is age in years as 20, 25, 30, 35, and the annual premium in rupees is 1,426, 1,581, 1,771 and 1,996. Now the first step is to mark age in years as X, annual premium in rupees as Y, and 20 mark it as X naught, 1,426 mark it as Y naught. Let us now find out the leading differences, that is delta to the power 1. How do we find out delta to the power 1? It is found as indicated by the arrows, that is in pink color. So it is 1581 minus 1426 gives us 155, denoted by delta naught to the power 1. Similarly, 1771 minus 1581 is 190. 1996 minus 1771 is 225. Now the leading differences should be written in between the values of the previous column. Next, find out delta square. Delta squared is nothing but the differences of the previous column. So 190 minus 155 gives us 35, which is denoted by delta naught square. And 225 minus 190 gives us 35. And now to find out delta cubed, it is nothing but the difference of the delta square column values, that is 35 minus 35 is equal to 0, and denote 0 as delta naught cubed. Newton's interpolation formula is given by consider yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cubed. Next, Write the formula for x, which is value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x. That means x is equal to value of x for which y is interpolated is given to us in the question. That is, we have to find out the premium at the age of 26 years. So that will be 26 minus 20 divided by the difference between two adjoining values of x, that is 25 minus 20, which is equal to 6 by 5, which is equal to 1.2. Now substituting all the values in the Newton's interpolation formula, we get, which implies y. Now the subscript will be 26 equal to 1426 plus 1.2 into 155 plus 1.2 into 1.2 minus 1 by 2 factorial into 35 plus 1.2 into 1.2 minus 1 into 1.2 minus 2 divided by 3 factorial into 0, which simplifies to 1426 plus 186 plus 1.2 into 0.2 divided by 2 into 35 plus 1.2 into 0.2 into minus 0.8 divided by 6 into 0, which gives us 1612 plus 4.2 plus 0. Therefore, y26 is equal to 1616.20. The premium at the age of 26 years is rupees 1616.20. 3. From the following data, interpolate the sales for the year 1998. So the first two columns are given to us, that is years, is 1996, 2000, 2004, 2008 and 2012. And the next column is sales in units as 47, 84, 105, 111 and 114. Now the first step is to mark years as X, sales in units as Y, and 1996 mark it as X naught, and the value 47 mark it as Y naught. Now we find out the leading differences, that is delta to the power 1, delta square, delta cubed and delta to the power 4. Now to find out delta to the power 1, it is a difference between the Y values, which is 84 minus 47 gives us 37. Mark it as delta naught to the power 1. Then 105 minus 84 is 21. 111 minus 105 is 6. And 114 minus 111 is 3. Now these values should be written in between the y values. Similarly, now find out delta square. Delta square is nothing but the difference between the values in the delta to the power 1 column. So 21 minus 37 is minus 16, mark it as delta naught square. Then 6 minus 21 is minus 15, 3 minus 6 is minus 3. Then find out delta cube. So delta cube will be minus 15 minus of minus 16, which gives us 1. Mark it as delta naught cubed. Then minus 3 minus of minus 15 gives us 12. The last column is delta to the power 4, which is 12 minus 1 equal to 11. And mark 11 as delta naught to the power 4. Solution. Write Newton's interpolation formula. Consider yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cube plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial delta naught to the power 4. Write the formula for x, which is value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x. So you get x equal to 1998 minus 1996 divided by 2000 minus 1996, which is equal to 2 divided by 4 equal to 0.5. Now substitute all the values from the table and do the calculations very carefully. So you'll get, which implies y 1998 is equal to 47 plus 0.5 into 37 plus 0.5 into 0.5 minus 1 by 2 factorial into minus 16 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 divided by 3 factorial into 1 plus 0.1 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 into 11, which gives us 47 plus 18.5 plus 0.5 into minus 0.5 divided by 2 into minus 16 plus 0.5 into minus 0.5 into minus 1.5 divided by 6 into 1 plus 0.5 into minus 0.5 into minus 1.5 into minus 2.5 divided by 24 into 11, which simplifies further to 65.5 plus 2 plus 0.0625 minus 0.4297. Therefore, y subscript 1998 is equal to 67.1328, and you approximate it to a whole number, that is 67. So you'll get the sales for the year 1998 is 67 units. Problem 4. Below are given the wages earned by workers per week in a certain factory. Calculate the number of workers earning more than rupees 650 per week. Now this particular problem is different and it is important. So in the first column you have weekly sales and the values are given in terms of the word up to. So you have up to 500, up to 600, up to 700, up to 800, up to 900, up to 1000. So here up to means it is less than, and you're also given the number of workers, which are 50, 150, 300, 500, 700, 800. So now what is the first step? Mark weekly sales as X, number of workers as Y, and the value 500 will be marked as x0 and 50 is marked as y0. Let us now find out the leading differences, and here you have the leading differences up to delta to the power 5. So form the columns delta to the power 1, delta square, delta cube, delta to the power 4 and delta to the power 5. By now you will know how to find out the differences and how to place the values. So it is 150 minus 50 is 100. Call it as delta naught to the power 1. Then 300 minus 150 is 150. 500 minus 300 is 200. 700 minus 500, 200. 800 minus 700 is 100. Next, find out delta square, which is 150 minus 100 is 50. Call it as delta naught square. Then 200 minus 150 is 50. 200 minus 200 is 0. 100 minus 200 is minus 100. Next, we calculate delta cubed. So 50 minus 50 is 0. 0 minus 50 is minus 50. Minus 100 minus 0 is minus 100. And 0, you will call it as delta naught to the power 3. Next, find out delta to the power 4, which is minus 50 minus 0 is minus 50. Call it as delta naught to the power 4. Then minus 100 minus of minus 50 will give us minus 50. Then in the last column, delta to the power 5 is minus 50 minus of minus 50, which gives us 0, and call it as delta naught to the power 5. Another important point to remember here is the given table is actually a less than cumulative frequency table. So the weekly sales, because they're all in terms of less than, is like less than class intervals, and the number of workers which you have is less than CF values. So the last value in the less than CF column is capital N, or in other words, capital N is equal to the total number of workers, which is equal to 800. Solution: Newton's interpolation formula will now extend up to delta naught to the power 5. So consider yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cubed plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial delta naught to the power 4 plus x into x minus 1 into x minus 2 into x minus 3 into x minus 4 divided by 5 factorial delta naught to the power 5. Now in this particular problem, we will first use Newton's interpolation formula to find the number of workers earning income of rupees 650 per week. And in the last step, we will compute the number of workers earning more than rupees 650 per week, because that's what is asked in the question. Please be very careful here. Now write the formula for x, which is value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x, which gives us x equal to 650 minus 500 divided by 600 minus 500, which is equal to 150 by 100 equal to 1.5. Substituting all the values in Newton's interpolation formula, you get y 650 equal to 50 plus 1.5 into 100 plus 1.5 into 1.5 minus 1 by 2 factorial into 50 plus 1.5 into 1.5 minus 1 into 1.5 minus 2 divided by 3 factorial into 0 plus 1.5 into 1.5 minus 1 into 1.5 minus 2 into 1.5 minus 3 divided by 4 factorial into minus 50 plus 1.5 into 1.5 minus 1 into 1.5 minus 2 into 1.5 minus 3 into 1.5 minus 4 divided by 5 factorial into 0. The further calculations, we get y 650 equal to 50 plus 150 plus 1.5 into 0.5 divided by 2 into 50 plus 1.5 into 0.5 into minus 0.5 divided by 6 into 0 plus 1.5 into 0.5 into minus 0.5 into minus 1.5 divided by 24 into minus 50 plus 1.5 into 0.5 into minus 0.5 into minus 1.5 into minus 2.5 divided by 120 into 0, which gives us 200 plus 18.75 plus 0 minus 1.1719 plus 0. Therefore, y 650 is equal to 217.5781, and you approximate it to 218 because we are finding out the number of workers. So in the next sentence, you will have the number of workers earning up to rupees 650 is 218, and the total number of workers which we have in the problem is 800. Therefore, the number of workers earning more than rupees 650 is 800 minus 218, which is equal to 582. Problem 5 is also important as it is different. From the following table, find out the number of workers earning wages below rupees 25 in hundreds. So in the first column, you have wages in hundreds of rupees as 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. And number of workers are 50, 80, 100, 75, 40 and 25. Now, mark wages in hundreds of rupees as the class interval and number of workers as F. Since we have to find out the number of workers who are earning below rupees 25 in hundreds, we have to first convert the given data into the less than frequency distribution. So the first column will now be wages in hundreds of rupees, and I'll call it as less than class intervals, which will be less than 20, less than 30, less than 40, less than 50, less than 60, and less than 70. The number of workers are less than CF. So we have to find out the less than CF values. So the values will be 50. Then 50 plus 80 is 130. 130 plus 100 equal to 230. 230 plus 75 is equal to 305. 305 plus 40 equal to 345. And 345 plus 25 equal to 370. So please practice this. And now the above data is in the correct format. We will now form the Newton's forward difference table and solve the problem. The first two columns will be wages in hundreds of rupees and number of workers. That's less than 20, less than 30, less than 40, less than 50, less than 60, and less than 70. The number of workers are 50, 130, 230, 305, 345, and 370. Wages in hundreds of rupees, you can mark it as X, number of workers as Y. Less than 20 will be X naught and the value 50 will be Y naught. Let us now find out the leading differences from delta to the power 1 up to delta to the power 5. So the delta to the power 1 values are 130 minus 50 is 80. Call it as delta naught to the power 1. Then 230 minus 130 is 100. 305 minus 230 is 75. 345 minus 305 is 40. 370 minus 345 is 25. Next is delta square values, that is 100 minus 80 is 20. Call it as delta naught to the power 2. 75 minus 100 is minus 25. 40 minus 75 is minus 35. 25 minus 40 is minus 15. Then delta cube values, minus 25 minus 20 is equal to minus 45 and label it as delta naught cube. Then minus 35 minus of minus 25 is minus 10. Minus 15 minus of minus 35 is 20. Next is delta to the power 4 is minus 10 minus of minus 45 will give us 35. Call it as delta naught to the power 4. 20 minus of minus 10 is 30. And in the last column, find out delta to the power 5. That is 30 minus 35 is equal to minus 5 and label it as delta naught to the power 5. Newton's interpolation formula is now consider yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cube plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into delta naught to the power 4 plus x into x minus 1 into x minus 2 into x minus 3 into x minus 4 divided by 5 factorial delta naught to the power 5. And x is value of x for which y is interpolated minus value of x at the origin divided by the difference between two adjoining values of x, which is x equal to 25 minus 20 divided by 30 minus 20, which is equal to 5 divided by 10 or 0.5, which implies y less than 25 equal to 50 plus 0.5 into 80 plus 0.5 into 0.5 minus 1 by 2 factorial into 20 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 divided by 3 factorial into minus 45 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 by 4 factorial into 35 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 into 0.5 minus 4 divided by 5 factorial into minus 5. So y less than 25 is equal to 50 plus 40 plus 0.5 into minus 0.5 divided by 2 into 20 plus 0.5 into minus 0.5 into minus 1.5 divided by 6 into minus 45 plus 0.5 into minus 0.5 into minus 1.5 into minus 2.5 divided by 24 into 35 plus 0.5 into minus 0.5 into minus 1.5 into minus 2.5 into minus 3.5 divided by 120 into minus 5, which gives us 90 minus 2.5 minus 2.8125 minus 1.3672 minus 0.1368. Therefore, y less than 25 is equal to 83.1835, which you approximated to a whole number 83. Therefore, the number of workers earning salary less than rupees 25 in hundreds are 83. The topic Newton's advancing method is important, and as the formula is lengthy, please be very careful in your calculations. Thank you so much for watching and look out for my next video.